Hello students, welcome back to our channel Abhyas IIT Prep. So today we are going to explain the 22nd Jan evening shift paper. Let's get into the video. So see this question number 26. If epsilon, E and T represent the free space permittivity and electric field and time respectively, then the unit of epsilon E by T. What is the unit of epsilon E by T? So we know that one epsilon units, just wait. We know that the units for the epsilon, so force by meter, or you can say this one coulomb by voltage into meter. So next one, see here, electric field can be written as V by M and a time in a second. So if you observe here, epsilon E by T is nothing but C by V into M into V by M 1 by S, that is second. If you cancel out V and V, you will get C by S into M square. C by S. So coulomb per second, that is nothing but current. That is, you can say this one ampere. So ampere per meter square. This is our answer. So option 3 is your answer. So next question, see here, 27. So this is from oscillations depending on the pendulum. What they are asking, using simple pendulum experiment, G is determined by the measuring its time period T. Which of the following plots represent the correct relation between length and time period? What they have given? They have given 1 by T square to L graph. So you have to find which is the correct graph. So we know that one time period T equal to 2 pi under root L by G. What they are asking, 1 by T square. So if you see this one, T square is nothing but 4 pi square L by G. So 1 by T square can be written as G by 4 pi L. So if you observe here, so 1 by T square is inversely proportional to length. 1 by T square is inversely proportional to length. So if you observe here, first graph is your right answer. It is inversely proportional to length, inversely proportional. So we have to find the collision frequency of the particle B. So we know that one collision frequency can be written as under root 2 pi d square into n into under root 8 RT by M. So temperature and number of densities are same. So you can write F is directly proportional to d square and inversely proportional to under root M. So we know that condition, a density of, so what is that one? The molecular size of a dA is molecular size, half of the molecular size of the B particle, and mass of molecule A is 4 times of the mass of molecule B. So substitute in this equation for A and for B. So FA by FB, what is this? You can say this one, so dA by dB into under root MB by MA. If you solve this one, substitute the values, dB by 2 by dB under root MB by 4 MB. If you substitute the values, you will get like this one. So if you cancel out these things, and you are remaining with 1 by 8. One more, we are having the value of B, gas B. So Fa can be written as frequency of the B particle, that is 32 into 10 to the power 18 by 8. So 4 times. So what is the correct answer? Option 2 is the right answer. So next question, see here, 29th question. So this question is from rotational mechanics. So conservation of angular momentum. So observe the question. So in question number 29, a uniform bar of length 12 centimeter and mass 20 m lies on a smooth horizontal table. 2 point masses m and 2m are moving in opposite direction with the same speed v. So observe here, this is our 2m mass which is moving with the velocity v, and this is our m which is moving with velocity v. As shown in figure, these masses strike the bars simultaneously, get stuck to it. After collision, the entire system is rotating with angular frequency omega, the value of v by omega. They are asking ratio of the v by omega. So from this one, so it can solve by law of conservation of energy, law of conservation of angular momentum. So we know that one. See here, in normal position, angular momentum can be written as mv or perpendicular. We are perpendicular. In rotation, you can say this one, angular momentum I omega. What is the I for the rod? What is the I for the bar? So bar can be written as mr square by 12. This is the I. So if you see here, law of conservation of angular momentum, Li equal to Lf. What is initial? What is initial? Initial, we are having 2m and m. So from this one, you can say this one, m. So I am writing here, m, velocity is the same, v into r. What is the r for m? So this is the perpendicular distance of 4. That is 4 plus the second mass, mass 2, 2m. So 2m into velocity v into, what is the perpendicular? Perpendicular distance. So that is nothing but 2. This is our initial angular momentum. Then next, what is that? I omega. So I am writing here I omega mr square by 12. So what is m? 20 m r square by 12 plus, for particles, m r square. What is that m? Distance. That is 4 square plus 2m into 2 square into omega. We know this one. Omega can be written as v by r. Omega can be written as v by r. So I am writing here v by r. This is our final equation. Here you have to take ml square by 12. Ml square by 12. What is this L? L is nothing but 12 centimeters. That is 12 centimeters. So if you observe here, if you solve this one, velocity by omega can be written as 33. If you solve this entire equation, you will get the value 33. So option 1 is the right answer. So next question, see here. Question number 30. A small identical bubbles of water having same charge on each coalesce to form a bigger bubble. Then the ratio of the potential on one initial bubble and that resultant bigger bubble. So three bubbles are there. They are forming one bigger bubble. So three bubbles are there. They are forming bigger bubble. So as per volume conservation, you can see this one. So volume is constant. So from this volume is constant, you can say this one, R equal to n to the power 1 by 3 R. This is our condition. R equal to n to the power R. What is the n? Number of bubbles, small bubbles, that is nothing but 3 to the power 1 by 3 into R. What they are asking? Ratio of the potential. So we know that one potential can be written as K Q by R. So potential is inversely proportional to R. We know that one. So potential of one initial bubble to that of a resultant bigger bubble. So VR by capital R, that is nothing but VR, you can say this one, inversely proportional R by 3R. So here R is nothing but 3 to the power 1 by 3 by R. Here you have to take small r. So if we cancel out, you are remaining with 1 by 3, 2 by 3. So you are remaining with this one. So option 4 is the right answer. So next question, see here, very simple but bit typical. So question number 31. What they are asking? In a parallax method, for the determination of a focal length of the concave mirror, the object should always be placed. So this question is from ray optics. So what is a parallax method? The method which is used for the determine the focal length in a concave mirror. If you observe here, see here, this is our concave mirror. If you want to find this focal length, we know this one, focal length and the radius of the curvature. So at which point you have to place the object? So between F and P, you won't get any focal length values of object. So what is the choice here? Beyond F. What is the choice here? Beyond F. So at a point beyond the focus of the mirror, that is the right answer. So next question, simple question only. Okay, see here, question number 32, hydrogen spectrum, very easy question. So this, the smallest wavelength of Lyman series is 91 nanometer. The difference between the largest wavelength of the Passion and Balmer series is nearly, what they are asking? Largest wavelength or maximum wavelength of the Balmer and Passion. So why they have given wavelength for the Lyman series? To find the R value. So see here, if you observe the pattern, this is our Lyman series. This is our Lyman series. Take it as n equal to 1 and one more is n equal to 2, that is a Balmer series, and one more is n3, n equal to 3, that is a Passion. One more is n equal to 4, that is nothing but a Fund series. If you observe here, what they are asking? A difference. So we know that one for a Lyman series, so 1 by L equal to R into 1 by N1 minus N1 square minus N2 square. So what they are asking? Smallest wavelength. How you are getting smallest wavelength? So N2 value is at infinity. So N1 at N1 minus N1 square minus 1 by infinity whole square. So you are getting R equal to 1 by lambda, that is nothing but 1 by 91. This is our our R value. So what you have to find now? You have to find the large wavelength of Paschen and Balmer series. So wavelength for Balmer series, I am writing here. See here, Balmer series. What is the R value? R value is nothing but 1 by 91. 1 by 91 in Balmer series. What is the N1? N1 is nothing but 2. So 1 by 4 minus 1 by 9. This is Balmer series maximum wavelength. Maximum wavelength. So if you observe here 1 by 91 minus the 36, so 5. So if you solve this one, you will get 655 nanometer. That is our Balmer wavelength. This is 1 by lambda. So next one, see here, Paschen, lambda p, that is nothing but 1 by 91. That is, take it as, what is the N1 here? N1 is nothing but 3, that is a 9 square. So 1 by 16. So what you are getting? You are getting 1872 nanometers. 1872 nanometer. If you have taken difference, so this is for lambda Paschen. If you taken difference, so lambda p minus lambda b, what is the value? 1872 minus 655, you will get 1217 nanometers. So what is the right answer? So option 3 is the right. So next one, see here, question number 33, which is from wave motion. So organ pipes are there, open organ pipe. So V3 and V6 are the third and sixth harmonic frequencies respectively. If V6 minus V3 equal to 2200 Hz, then the length of the pipe is. They have given velocity of the sound. What do you have to find? You have to find the difference between a sixth and third harmonic frequencies. What is the frequency formula from this open pipe? So frequency of open pipe can be written as n into velocity of the sound wave by 2 times of the length. So the difference between V6, what is the V6? So V6 minus frequency, or you can say this one F6. F6 minus F3 equal to 2200. F6 can be written as 6V by 2L minus 3V by 2L, that is nothing but 2200. So 3V by 2L, that is V is nothing but 330 meter per second by 2 into L, 2282200. So if you observe here, so L value you will get the 225 millimeters. 225 millimeters. So question number 34, which is from mechanical properties of the fluids, which is based on the capillarity. So what is the question here? When a part of a straight capillary tube is placed vertically in a liquid, rises up to a certain height h. If the inner radius of the capillary tube and the density of the liquid and the surface tension of the liquid decreased by 1% each. It is decreased by 1% each. So decreased by, you have to take negative sign. So then the height of the liquid in the tube will be changed by. So we know that one from the capillarity, height h equal to, you can say this one, 2t cos theta by rho gr. Rho gr. What they are asking? They are asking for the height, percentage change in height. So percentage change in height, delta h by h percentage is nothing but delta T by T minus delta rho by rho minus delta R by R. So, surface tension is decreased by 1%, density is decreased by 1%, and R, radius, is also decreased by 1%. So, I am writing here equal to minus 1% decreased minus of minus 1% decreased and minus 1%. So, you will get the plus 1% is the change in height. So, option 4 is the right answer. So, next question, see here, question number 35, which is from electronic devices, which is based on the logic gates. What they are asking? Correct truth table for the given input data. So, they have given some logic gates. What do you have to find? You have to find the truth table of it. So, see here, inputs, AND gate is there, or AND is there, NOT gate, NOT gate. So, inputs A, B. So, here you will get A dot B. So, from this one, you will get A dot B whole bar. So, similarly, from this one, you will get C plus D. C plus D. So, at this D point, what you are getting? You are getting A dot B bar dot C plus D dot C plus D. Just write dot C plus D. C plus D. So, at Y output, what you are getting? A dot B whole bar dot C plus D whole bar. As per our Boolean algebra, so A dot B whole bar plus C plus D bar. If we cancel out A dot B plus C plus D whole bar. So, you have to check this output with this given table. If you observe second table, you will get the answer. So, Y can be written as what is it? A dot B. What is A here? 1 and 1. 1 dot 1 plus C is 0 and D is 1. So, 0 plus 1 whole bar. What do you have to get? You have to get the output 1. So, 1 plus 1. This is 1 bar, that is nothing but 1 plus 0, you will get 1. So, if you observe the second table, this is your answer. So, let's get into the next question. So, question number 36, which is from current electricity, so which is based on the efficiency. So, the electric power line having total resistance 2 ohm delivers 1 kilowatt power. They have given voltage also 250 voltage, the percentage efficiency of the transmission line. So, they have given power is nothing but, so power they have given 1 kilowatt, kilo can be written as 1000 watt. So, power formula, we know that power is nothing but V into I have to find I. So, what is V? V is nothing but 250 into I. Power they have given 1 kilowatt. Here you have to write, just wait, I am writing outside. That is nothing but power 1000. So, I can be written as 4 amperes. What they are asking? Percentage of efficiency. So, percentage of efficiency can be written as V equal to power loss by power total, net power into 100. This is our efficiency formula. So, from this one you can write what is the power loss. Power loss can be written as I square into V. So, that is nothing but 16 into 2 that is nothing but 32 watt. So what is the total power? So total power can be written as 1000 plus 32, you can simply 1032 watt. So here you will get a 1000 by 1032 into 100. So this is our efficiency. If you cancel out the things, you will get the answer 96.9%. So option 1 is the right answer. So next question, see here, question number 37 from the ray optics. So which is purely based on the refractive index. So see that question. The wavelength of light while it passing through the water is 540 nanometers. The refractive index of the water is 4/3. The wavelength of the same light when it is passing through the transparent medium having the refractive index 3/2. So what they are asking for the wavelength of the second medium. So we know that formula, refractive index can be written as C by V, that is the velocity of the light by velocity of the light in a medium. So from this one we know that velocity formula, velocity can be written as frequency into lambda. So velocity is directly proportional to lambda, that is wavelength. So refractive index is inversely proportional to velocity. So from this one you can conclude refractive is inversely proportional to F and inversely proportional to lambda. What we have to find? We have to find the wavelength. So we should want only wavelength. So mu1 by mu2 is equal to lambda 2 by lambda 1. So you have to find the lambda 2. So lambda 2 can be written as a lambda 2 is nothing but a lambda 1 into mu1 by mu2. So what is lambda 1? 540. What is lambda 1? 540 into mu1 4/3 into 2/3. Mu2 3/2. I have reversed it. So next one, see here, 9 gets cancelled, 60. So 60 into 8, 480 nanometers. That is the wavelength in second medium. So what is the correct answer? Option 3 is the right answer. So next one, see here, question number 38, which is from electromagnetic induction. So which is based on the inductor. What is the query? Figure shows the electric circuit that contains the 3 resistors, 9 ohm, 3 resistors are there, and 2 inductors of having 2 millihenries. Inductors is having 2 millihenries. The reading of ammeter at the moment when the switch is turned on. See here. If you see this is switch is turned on, then what is the current in the circuit? What is the reading of the ammeter? So when the switch is turned on, then inductor is open circuit. Inductor is open circuit when this switch is turned on. So then what will happen to the circuit? See here, I am writing, this is our ammeter and this is, that is open circuit. This is 9 ohm and one more resistance is there. This is also 9 ohm. So one more 9 ohm, but it is open circuit. This is 9 volts. What they are asking? Reading of the ammeter. So ammeter I can be written as 9 by 9. You will get 1 ampere. Which is the right answer? Option 1 is the right answer. So next question, see here, 39. Question number 39. So see that question. The question is from gravitation and which is based on the motion of the satellite. Moderate question only. What they are asking, statement 1, statement based questions. In this paper we are having 3 statement based questions. So statement 1, the satellite is moving around Earth in the orbit very close to the Earth's surface. The time period of revolution of the satellite depend on the density of the Earth. So what they are saying, the time period of the satellite is depending on the density of the Earth. Is that right or wrong? Check here. So time period can be written as T equal to 2 pi under root R cube by M. So what is the value of M? We know that one. From this, M is nothing but density into 4 by 3 into pi R cube. This is nothing but volume and this is density. So what is the conclusion? So statement 1 is right. True, it's true. So because time period is depending on the density of the Earth. So what is the second statement? The time period of revolution of the satellite, they have given time period equation T equal to 2 pi into under root R by G. What is this R? R is nothing but the radius of the Earth and G is nothing but acceleration due to gravity. Is that true or not? Check here. So we know that one, G value, G can be written as Gm by R. So if you substitute in time period, you will get T equal to 2 pi under root R by G. So statement 2 is also right answer. So 2 statements are true. So which is the correct option? So both statement 1 and 2 are true. So next question, see here, one more question which is from wave optics. So see here, YDSC, actually it is from. So see here, the width of central maxima increase with the increase in wavelength keeping its slits constant. So what they are asking, they are concentrating on the width of the central maxima is increasing. What is the condition? Width of the central maxima increasing. Width of the central maxima increasing. Width of the central maxima is increasing. So brightness of the central maxima is increasing. So they are asking in the aspect of the width of the central maxima. So we know that one, for width you can say this one 2d. Actually you have to write a small d, that is the distance between the screen and the slits. 2d lambda by small d. Small d is nothing but distance between the two slits. So which is correct? So B is directly proportional to lambda and B is directly beta. So not B, beta is directly proportional to capital D and beta is inversely proportional to small d. So increase with the wavelength, keeping the slits. Increase in wavelength. So it is directly proportional. Option A is the right answer. So option B, width of the central maxima is increased with a decrease in wavelength. So decrease in wavelength, that is wrong because beta is directly proportional to lambda. So next one, see here, option C, width of the central maxima is increased with a decrease in slit width. So this is also right because it is inversely proportional. If beta is increasing, slit width is decrease. So that is also right answer. So width of central maxima increase with the increase in slit width. This is wrong. It is contradiction to option C. So the brightness of the central maxima increase for the decrease in wavelength at constant slit. Decrease in wavelength at constant width. So brightness is directly proportional to wavelength. So that is also right answer. So option A, C and E are the right. Option A, C and E are the right answer. So next one, see here, question number 41, given two statements, statement based question again. So what they are asking, an object moving from position R1 to R2 under conservative force field F, the work done by the force is. They have given work done W equal to minus F dr. So what they have given, work done equal to minus F integral R1 to R2 dot dr. This is wrong. For conservative force, that is wrong. You are not getting negative sign here. So what should be like? So R1 to R2 F dr. This is right. So statement 1 is the wrong. What is the second statement? See here. Any object moving from one location to another location can follow the infinite number of the path before. So therefore, the amount of work done by the object changes with the path following it for a conservative force. So if we are having, this is our initial position, x initial, we are having another position, x final. So one path is there, path 1, next path is there, path 2, and path 3 is there, path 4 is there. So in case of conservative force, the path, when the path is changed, the work done is changed. So this is wrong. So conservative force is independent of path. What is that one? Independent of path. Independent of path followed. So option 2 is also false. So what is this one? Both the statement 1 and 2 are false. So next question, see here, question number 42, very tricky question. So which is from electrostatics based on the potential and the electric field. So they have given one charges having Q are placed at the vertices of a pentagon as shown in figure. The electric field, potential and electric field at the center of the pentagon due to the 5 charges. So for regular polygon, what is that one? Regular polygon. For regular polygon, electric field is 0. For regular polygon, electric field is 0. If you take a triangle or a square, so electric field is 0 at center. So what is about the potential? Potential can be written as all charges are plus Q. You have to just add V1, V2, V3 plus V4 plus so on V5. So you will get a 5 KQ by R. K is replaced by 1 by 4 pi epsilon. So option 1 is the right answer. I hope you are observing. So next question, see here. Okay, what is the question? Question number 43. A laser beam has the intensity. What they have given? Intensity. The amplitude of a magnetic field associated with beam. What they are asking? Magnetic field. Amplitude of magnetic field. So we know that one magnetic field amplitude. So B naught can be written as E naught by C. What is E naught? Amplitude of the electric field. What is C? C is nothing but velocity of the light. So E naught can be written as equal to E naught equal to, in case of intensities, they have given in intensities, 2I by epsilon naught into C. What is C? Velocity of the sound, and epsilon naught they have given value. So if you see here, B naught equal to epsilon by E naught by C, that is nothing but 1 by C. What is the value of a C? That is 3 into 10 to the power 8 under root 2 into 10 to the power sorry, 2 into 10 to the power 14 into 4, I am writing reverse, no need to get tension. So 8.85 into 10 to the power minus 12 into C, that is nothing but 3 into 10 to the power 8. So if you calculate this entire thing, you are remaining with 1.83 Tesla. So this is your magnetic field amplitude. Next one, see here, question number 44. The light is incident on the metallic plate having work function, which is from the photoelectric effect, modern physics. If the produced photoelectron have zero kinetic energy, then the angular frequency of the incident light. What they are asking? Angular frequency, omega they are asking. So we know that when omega equal to 2 pi nu, that is nothing but frequency. We know that frequency phi equal to h nu. So from this one, nu can be written as phi by h. Phi by h. So if you write angular frequency 2, so see here, so 2 can be written as, how to write? Okay, 2 into 3.14 2 pi. What is the frequency? Phi by h. What is phi? They have given work function phi 110 into 10 to the power minus 20 by h. What is the h? 6.63 into 10 to the power minus 34. So see here, if you solve this, you will get the answer 1.04 into 10 to the power 16. How do you solve it? Option 1 is the right answer. So next question, see here, question number 45. So we come across almost 4 questions which is based on the theoretical questions. So you should be aware of the theory. So what is the question? See here, for a mechanical system of many particles, total kinetic energy is the sum of the kinetic energies of the all particles. What they are asking? So in a system, the total kinetic energy of the each particle is equal to total kinetic of the system. So what is kinetic energy of the total system is nothing but individual kinetic energies of the particle 1, m1 v1 plus half m2 v2 whole square. That is the right statement 1 is true. What is about statement? Statement 1 is true. What is about statement 2? The total kinetic energy can be sum of kinetic energies of the center of mass with respect to origin and the kinetic energies of the all particle with respect to the center of the mass as a reference. So kinetic energy with respect to center of mass, so half m1 plus m2 at the center of mass whole square plus half m1 m2 by m1 plus m2 at v1 bar minus v2 bar whole square. So from this one, statement 2 is also true. So what is the right answer? So both statements 1 and 2 are true. Option 1 is the right answer. Next question, that is from part 2, numerical questions. So see here, according to a conducting, so what is the question number 46? Question number 46, what is that one? A conducting circular loop is rotating about its diameter at a constant angular speed of 100 radian per second in a magnetic field of 0.5 Tesla perpendicular to the axis of rotation. What they are asking? They have given one conducting circular loop which is a rotating, having angular velocity perpendicular to the axis, which is having magnetic field B. 0.5 is nothing but 1/2 Tesla. When the loop is rotated by 30 degrees, so the loop is rotated by 30 degrees, theta equal to 30 degrees from the horizontal position, the induced EMF is 15.4 millivolts, the radius of the loop is. What they are asking? They are asking for the radius of the loop. So see here, we know that one induced EMF can be written as EMF E can be written as B omega A sin omega t. A sin omega t. I am writing again A sin omega t. So we know that one sin 30 is nothing but simply 1/2. What is the A? A is nothing but area pi r square. That is, what is r? Constant field. So you have to find the r. So that is the question query. So r square, angular speed, radian per second. So E can be written as a 15.4 into milli, that is nothing but 10 to the power minus 3 equal to magnetic field 1/2 into 100 area pi r square, that is nothing but 22/7 r. You have to find r into 1/2 into 1/2. So you have to find the r value. So if you find r, you will get the 14 millimeter. What is the r value? If you solve this equation, you will get the 14 millimeter. 14 millimeter. So see that next question. Two masses M and M2 are connected by a light string going over a pulley of disc M. Mass they have given pulley mass 30 m with radius 0.1 meter. The pulley is mounted in a vertical plane. It is free to rotate about its axis. The 2m mass is released from the rest. Its speed is when the descended through height 3.6 meters. What they are asking, which is from rotational mechanics, conservation of energy, based on the pulley problem only. So what they are asking, we are having two masses. We are having one pulley here, two masses m and 2m. Take this. This is m. This is our 2m. Okay. So I am writing little bit higher 2m. So this is our 2m. So this is the condition. If we release it that 2m, it will go down with the height of h. With the height of h, that is 3.6 meters. So then what you have to find? You have to find the velocity. So law of conservation of energy. Law of conservation of energy. Initial energy equal to final energy. Excuse me. So kinetic energy initial plus kinetic energy initial plus initial potential energy equal to so kinetic energy initial plus potential energy initial equal to final kinetic energy plus final potential energy. So initial case there is no kinetic energy, so initial kinetic energy is 0. So what is initial potential energy? That is mgh, mass into gravity into height. The final potential energy is 0. Final potential energy is 0 because it is in motion. It is in motion. The pulley also rotating with the angular velocity omega. Remember this. So what is the final kinetic energy? Kinetic energy due to two masses plus a pulley. So I will tell you. See here. 1 by m v square plus 1 by 2m. So this is 2m v square plus what is the kinetic energy in a rotation motion? So half I omega square. Half I omega square. So what is the pulley? So kinetic energy in a rotational motion half I omega square. So in this case omega can be written as V by R. So I is nothing but m r square by 2. What is the mass of the pulley? They have given 30m. Mass of the pulley is nothing but 30m. So take here 30m. Take here 30m. 30m. R square into V square by R square. If I cancel out R square, you are always remain with V. So if you find out velocity, so mgh equal to 9 mv square. If you cancel out each and everything, you will get this one 9 mv square. So mm gets cancelled. You must have v. So that is nothing but g into h by 9. That is g is nothing but 10, h is nothing but 3.6 by 9. Root 4, that is nothing but 2 meter per second. Velocity is nothing but 2 meter per second. So next one, see here, question number 48. Capacitors, based on the capacitors, electrostatics, capacitors. So the capacitor P with the capacitance, they have given 10 into 10 to the power minus 6 is fully charged with a potential difference 6 volts and disconnected from the battery. The charged capacitor P is connected across the another capacitor Q with the capacitance 20 into 10 to the power minus 6 Faraday. The charge on the capacitor Q when the equilibrium is established. So alpha they have to find. We have to find the alpha value. What is the equilibrium condition? So equilibrium condition is nothing but potential equal to 0. So see here, what is the first condition? So capacitor C1, they have given C1. What is the C1 value? C1 is nothing but 10 into 10 to the power minus 6. I am taking 10 to the power minus f. And what is V1? 6 volts. Second condition at equilibrium. So V2 equal to 0. And what is C2? C2 is nothing but 20 into 10 to the power minus 6. That is nothing but 2 into 10 to the power minus 5 Faraday. So you have to find the potential. So potential is nothing but C1 V1 plus C2 V2 by C1 plus C2. So this is V2 is 0. That's why this term is 0. So C1, that is nothing but 6 into 10 to the power minus 5 by 3 into 10 to the power minus 5. C1 and C2. So this is nothing but 2 volts. Voltage they have given by, we have remain with that 2 volts. What do you have to find? Charge. You have to find the charge. So what is the charge? Charge is nothing but a Q equal to C into V. Q equal to C into V. So this is our capacitors 2. So we are having a 2 into 10 to the power minus 5. What is the voltage? V equal to 2. So 4 into 10 to the power minus 5 coulomb. So alpha is nothing but 4. What is the value of alpha? Alpha is nothing but 4. Next question, see here, 49. Question number 49. A cylinder conductor of length 2m and area of cross section they have given 0.2 millimeters. I am writing here area of cross section 0.2 millimeter square. If you write 0.2 to 10 to the power minus 6 meter square or 2 into 10 to the power minus 7 meter square. This is our area. Carries an electric field 1.6 amperes when its ends are connected to a 2 volts battery. The mobility of electrons in the conductor is. So they have given some value. You have to find the alpha value. The value of alpha. What is the mobility formula? So mobility mu can be written as drift velocity by electric field. So from this one, electric field can be written as E can be written as so V by L. What is V? 2. What is L? 2. So 1. So E value is 1. So what is the mobility? Mobility is nothing but a drift velocity. What is drift velocity? I equal to NEA. What is N? They have given electron concentration. What is I? 1.6 by what is electron concentration? 5 into 10 to the power 28 into electron value 1 into 10 to the power minus 19 coulomb. And what is area? Area I have written already. So 2 into 10 to the power minus 7. So if you solve this entire problem, so you are remaining with 1.1 into 10 to the power minus 3. So what is the value of alpha? So alpha is nothing but 1. Value of alpha is nothing but 1. So which is based on the drift velocity and mobility. So see here next question. Question number 50. An insulator cylinder of a volume, they have given volume which is from thermodynamics and ideal gas equation. So an insulator cylinder of a volume, they have given volume equal to 60 centimeters is filled with a gas at 27 degrees centigrade. So you have to convert into kelvins. So under 2 atmospheric pressure, then the gas is compressed, making the final volume, allowing the temperature to rise 77 degrees centigrade. This is also you have to convert into kinetic. So kelvins, the final pressure is. So we know that one PV equal to nRT. PV equal to nRT. So from this one you can write P1 V1 by T1 equal to P2 V2 by T2. What they are asking? Final pressure they are asking. We have to find P2. What is P1? What is P1? 2 atmospheric pressure. So 2 into 10 to the power 5. What is V? V is nothing but 60 by what is temperature? 27 degrees. You have to convert into kelvins. So 273. You have to find P2. P2 and volume they have given 20 by 77 plus 273. Okay. So if you find P2, if you find P2, you will get 7 into 10 to the power 5, that is nothing but 7 atm atmospheric pressure. So what is the answer? 7 is the your answer. So This is our end of the video. So if you are having any doubts, please comment below. Thanks for watching. Bye.